And today let's take a look at quantipose number 56, another combinatorics one and another set partitions one. So let x be this set and y be this set. So how many functions from x to y are surjective? So what exactly does surjective mean? Well, I have my domain over here, right? All of my possible x values. And then my codomain is over here with all my possible y values. And for a function to be surjective, every single one of these values needs to get mapped to, right? For instance, this mapping right here would not be surjective because D never got mapped to. So this is just a straight up reframing of the ice cream truck problem. So let's just find the total number of possible functions from x to y and then subtract off the ones that are not surjective. So first let's calculate the total over here. I know that for every value in my domain, of which there are 8, they have 4 places that they could possibly map to, right? A, B, C, or D. So for instance, 1 could map to 4 different things. For every valid mapping of 1, 2 could map to 4 different things, right? A, B, C, or D. So could 3, so could 4, right? This goes on 8 times. So what is the total? It's going to be 4 to the power of 8. Now I have to subtract off my non-surjective functions, which just means one of the values in our codomain did not get mapped to. So what are the number of ways that I can do that? So again, it's just going to be basic inclusion-exclusion, just like we did for the ice cream truck. So first, let's just say D can no longer be mapped to. So how many valid mappings remain when we do this? Well, we still have 8 elements in our domain, and we're mapping now to 3 different values over here. So each one of them could map to any of 3 values, and there's 8 of them, so we get 3 to the 8th. So now let's look at the number of functions that do not map to C, but now they can map to D, right? And we're going to get the same answer, right? We have 8 elements and 3 to map to, so also 3 to the 8th. And we're going to get the same thing for every way that we can cross off one element. So how many ways are there for us to cross off one element? Well, it's going to be 4 choose 1 equals 4. So now it's just inclusion exclusion. We know that when I crossed off D, there are still some functions that I calculated in there that also didn't map anything to C, so we're overcounting. We subtract off the number of ways to choose 2 elements from our codomain, and then when we do that, we're going to have 2 elements to map to and 8 values in our domain. So it's going to be 2 to the 8th. And we know we have to add back on the cases where we choose 3 elements out of our 4 to be crossed off. And in that situation, there's only one way to map every single element to one value, right? So it's just going to be times 1. And now we're good. We can just take our total and subtract off the number of non-surjective functions. So we're going to get 4 to the 8th minus 4 times 3 to the 8th plus 4 choose 2, which is actually going to be 6 times 2 to the 8th. Now minus 4 choose 3 times 1, which is just 4. And when we work this all out, we just wind up with 40,824.